Okay, so let's test out some network sniffing tools. First of all, let's start from something you can find in almost every Linux or Unix distribution nowadays. It's TCP dump, right? In order to run it, you will definitely need root permissions because it automatically switches the default interface or the interface you specify to promiscuous mode, right? But to see the help message, it's okay to be a regular user. So as you see, although I use Homebrew for almost all my tools, this one is provided by Apple, and it uses libpcap. This is a shared library that is used by Wireshark, T-Shark, and basically every other modern utility that does packet sniffing. So let's construct the command that will capture traffic in our Wi-Fi interface. Yeah, so it will look like sudo tcp dump interface en0. Let's write it to an external file. Right, and yeah, that's it for now, I guess. Okay, so it's listening. So something happens. Let's open another window and generate some traffic. Okay, let's ping google.com. Yeah, so what we have here, let's send out 20 packets. Okay, 21 packets sent, 21 packets received. And here, let's stop capturing and we see some statistics. We have captured 388 packets. Yeah, and all of them most probably have been written to the capture file, which is tcp dump capture file, the version, little endian. Okay, so let's now read it by tcp dump and look through. So this is how it looks like. Every line shows a packet, it shows the source, shows the destination, it shows of course the TCP ports used, source port, destination port, and so on, and it sees shows you the direction, the number, the timestamp, and so on. So these are TCP flags. This is sequence number. This is the TCP flags installed, right? The window size, the options. So this is all basically just metadata that surrounds the actual traffic that is passed. So you can, of course, this is not the text data that is stored in this file, right? So if we try to read it as text, we will fail because basically it's just the binary data that represents actual packets that are transmitted over the wires or over the air, okay? But when you read it by this little option -r, it converts it to something readable. We can of course increase the verbosity and show much more data for each packet, okay? So it's now, oh sorry, if you double V, it will be different, or it won't. Yeah, it will. So if you just add V, no matter how many of them, you will see a little bit more. So there will be flags, offsets on IP, and the type of service information, the length of the packet, its type, and so on. So it will be more detailed, but basically no additional information is provided. It's just another way to to show the same thing. So basically that's it. Yeah, so that's all you can use TCP dump easily for. However, there is, for example, a way to filter incoming data, so it will just filter something out, yeah, based on the criteria you provide. For example, for the same interface, yeah, and saving to the same file, we can provide filter. Let's for example say we want only Google.com traffic. Okay, let's see what happens. Let's ping this Google.com for 5 times. Okay, and we have 10 packets captured while 51 packets received. You see, so this means that only 10 packets that we have just generated to Google.com and received back, yeah, they were saved into the file. Let's check it out. Yeah, that's it. Just 10 lines representing ICMP ACK requests and ICMP ACK replies corresponding to those requests. Okay, so yeah, that's it. We of course can then use these pickup files to do much more interesting things. For example, to script processing via Skeppy, or just open in Wireshark and read through them and try to do other more complex operations. But as for TCP dump, I think this is the main things you could do, right? So this expression representing the filter follows everything else. Okay, so let me show you something more complicated, not just host Google. Okay, so let's say it's host Google, and AT or TCP port like this. Okay, so let's now again generate some pings. Yeah, then let's netget to Google.com port 80 and try to get some HTTP traffic. Okay, we got redirect. Okay, that's neat. And now let's generate this HTTPS traffic as well. Same result. Okay, yeah, and now let's end up by stopping the capture. We see only 76 packets captured, while overall traffic was much more intensive. Okay, so let's read that. You see, let's for example grab everything that does not relate to HTTPS. Okay, okay, and filter everything that does not. Now let's make it more universal. You see, nothing is there. Okay, so our pings are just not there. As you remember, we have created the filter that just limited our capture to TCP traffic only on ports 80 and 443. Okay, now let's verify that this works both ways. So when we read the capture, we can also create these filters. For example, not TCP, port 80. Okay, what we can see, only HTTP traffic is there, right? So this is kind of cool. This shows what you can do from the command line, even if you have just limited access via SSH or Telnet or your Metapreter agent deployed in some other way, right? So this is it.